Have you ever used nail polish remover? Or maybe paint thinner to clean a brush? If you have, then you've used a solvent. Solvents are amazing liquids. They have a special superpower. They can dissolve other substances. Think of it like this. When you stir sugar into water, the sugar seems to disappear. The water is acting as a solvent, dissolving the sugar to create a solution. Solvents are all around us, often hiding in plain sight. Permanent markers, everyday products. Cleaning sprays, everyday products. They are the unsung heroes of chemistry, making things mix and work together. So, why are these dissolving liquids so incredibly useful? Consider this. Science. Solvents are the workhorses of laboratories and factories, used to make medicines, used to extract important compounds from plants. At home they help remove sticky labels, get rid of tough grease stains, and even assist in cleaning during electronics manufacturing. Their ability to break down and carry other materials makes them indispensable. Without solvents, many reactions and manufacturing processes wouldn't be possible. Fundamental to science, industry, and daily chores. But here's the thing. Useful doesn't mean harmless. The same property that dissolves paint can harm skin or lungs and damage the environment. If it can dissolve dried-on paint, what might it do to your skin? Or if you breathe it in? That dissolving power can be a double-edged sword. This hidden danger we all need to understand. Respect the science. These liquids require careful handling. Not about being scared, about being smart and prepared. This is why we need to talk about solvent safety. Student in a chemistry lab, artist in a studio, mechanic in a garage, someone doing deep cleaning at home. Know how to handle them safely. Protect yourself, others, and the planet. Learn the risks and simple steps to stay safe so you can keep using these tools without harm. Let's get ready to dive into the science of solvent safety. Let's start with a very flashy hazard, flammability. Many common solvents, like acetone, the main ingredient in many nail polish removers, or ethanol, are extremely flammable. This means their vapors can catch fire very easily. All it takes is a tiny spark from static electricity, a hot surface, or an open flame, and whoosh! You could have a dangerous fire on your hands. The vapors are often heavier than air, so they can travel along the floor or a workbench to an ignition source far from the container. That's why you should never, ever use flammable solvents near anything that could create a spark. It's a serious risk that demands serious respect. Next up is toxicity. This means the solvent can be poisonous if it gets into your body. This can happen in a few different ways. You might breathe in the fumes, which is called inhalation. You could accidentally swallow it, which is ingestion. Or it could soak through your skin, which is known as absorption. Solvents like methanol, found in some windshield washer fluids, are very toxic. If ingested, they can cause blindness, or even be fatal. Other solvents can cause dizziness, headaches, and nausea. Your body is a complex chemical system, and introducing a powerful solvent can disrupt it in very dangerous ways, so keeping them out of your body is priority number one. The third primary hazard is reactivity. This one is a little different. Some solvents can have violent chemical reactions when they're mixed with other substances. For example, some organic solvents can react explosively with what we call oxidizers, like bleach or certain acids. This isn't just a simple fizz or bubble. We're talking about a reaction that can release a huge amount of energy very quickly. It can cause an explosion, release toxic gases, or start a fire. This is why you must never play amateur chemist and mix chemicals unless you know exactly what you are doing. Always read the safety labels to see what a solvent should not be mixed with. So there you have it. The big three primary hazards. Flammability, the risk of fire. Toxicity, the risk of poisoning. And reactivity, the risk of a dangerous chemical reaction. Each of these dangers is significant and requires your full attention whenever you are handling a solvent. Understanding these risks is the first and most critical step in using these chemicals safely. It's like learning the rules of the road before you start driving a car. Knowing what can go wrong helps you make sure everything goes right. These aren't just abstract concepts. They are real-world dangers we must prepare for. Beyond the immediate dangers of fire poisoning, there are sneakier, less obvious hazards that we need to talk about. The first one is long-term health effects from chronic exposure. This means being exposed to small amounts of solvent fumes over and over again for a long time, weeks, months, even years. Some solvents, like benzene carbon tetrachloride, are known carcinogens. Others can cause damage to your internal organs, like your liver, kidneys, nervous system. These effects might not show up for a very long time, It's a slow-motion danger that builds up over time. Another secondary hazard is the damage solvents can do to our environment. When solvents are poured down the drain or dumped on the ground, they can seep into the soil and contaminate groundwater. When they evaporate into the air, some can contribute to smog damage the ozone layer. These chemicals can be toxic to fish, birds, other wildlife. Proper disposal isn't just a rule. It's our responsibility to protect our shared planet. What we do in our lab, garage, kitchen can have a ripple effect on the world around us. Then there's the risk that comes from improper storage. Storing flammable solvents in a hot area, like a sunlit shed near a water heater, dramatically increases the risk of a fire. Keeping reactive chemicals next to each other on a shelf is like setting a trap waiting to be sprung. Even the container itself can be a hazard. If a solvent is stored in a container that it can dissolve, like certain plastics, it can leak out, creating a spill, releasing hazardous fumes, and creating a huge mess that is also a safety emergency. These secondary hazards, long-term health issues, environmental harm, storage risks, are just as important as the primary ones. They are subtle, but their consequences can be just as severe. They remind us that solvent safety is not just about avoiding a single dramatic accident. It's about developing consistent, safe habits that protect our health and our world over the long run. It requires thinking ahead and considering the full life cycle of the chemical, from the moment you open the bottle to the moment you dispose of the empty container. Being a safe scientist means being a responsible one too. So how do we handle these powerful liquids safely? Well, it all starts with one of the most important rules: ventilation, ventilation, ventilation. Always work in a well-ventilated area. If you're inside, open windows, open doors, use a fan to keep fresh air moving. In a lab, use a chemical fume hood. Good airflow disperses hazardous vapors, reducing the concentration you might breathe in. It lowers the risk of toxicity and flammability by preventing vapors from building up. Never work with solvents in a small, enclosed, unventilated space, closet, bathroom. Next, protect your body with personal protective equipment, PPE. This is your personal armor against splashes and fumes. Always wear safety goggles. A single splash can cause permanent eye damage. Wear gloves resistant to the solvent you're using. Not all gloves are equal. Wear a lab coat. Use a respirator for highly toxic solvents. Read the solvent's safety data sheet, or SDS, for PPE guidance. Fire safety is non-negotiable. Know where the nearest fire extinguisher is and how to use it. Use the correct type, usually Class B for solvents. Eliminate ignition sources. No open flames, no smoking. Avoid sparks from electrical equipment. Have a fire safety plan. Preparation prevents small problems from becoming catastrophes. Finally, spills and waste. Accidents happen, so be ready. Keep a spill kit with absorbents. Special pads, cat litter. Use absorbents to contain a small spill. Never pour solvents down the drain. Don't throw them in the regular trash. Collect waste in a clearly labeled, sealed container. Follow disposal guidelines from your school, workplace, or local hazardous waste facility. As we've seen, solvents are truly remarkable chemical tools. They are essential to countless processes in science, industry, our daily lives. From creating life-saving medicines to helping us with simple tasks at home. Their ability to dissolve other substances makes them incredibly powerful and versatile. We rely on them in more ways than we probably realize. They are a testament to the power of chemistry to solve problems and create the modern world that we all inhabit. Their usefulness is undeniable, but with that great utility comes a great need for caution and awareness. It's a balance we must always maintain. However, that power demands our respect. The very properties that make solvents so effective are also what make them hazardous. We've explored the primary danger: flammability, toxicity, reactivity. These can cause fires, poisoning, and explosions. We've also uncovered the secondary, sneakier dangers: long-term health effects from chronic exposure, harm to our environment, and the risks associated with improper storage. Ignoring any of these hazards is a gamble with your health and safety. Respect for the chemical means understanding its full potential for both help and harm. The good news is that staying safe is entirely achievable. It's not about being afraid of solvents. It's about being educated and prepared. By following simple safety procedures, you can minimize the risks to almost zero. Always ensure you have great ventilation. Always wear the right personal protective equipment, like goggles and gloves. Be mindful of fire safety and know your plan. And always handle storage and disposal with care and responsibility. These steps are your shield, protecting you from the hidden dangers and allowing you to harness the power of solvents for good. So, The next time you pick up a bottle of paint thinner, a cleaning agent, or work in a lab, take a moment to think. Read the label. Check your ventilation. Put on your safety gear. By treating every solvent with the respect it deserves, you are protecting yourself, protecting your community, and protecting our shared world. Science is awesome, and using it safely makes it even better. Be smart, be safe, and keep exploring the amazing world of chemistry with confidence and caution. Your future self will thank you for it. Consider it an investment in a long, healthy life.